Well, good morning, freshmen. We are back at it. I hope you guys are making some good progress on your exponential growth assignment from Monday. Remember, if you have any questions or want to run anything by me, go ahead and just text me or email me, and we'll get you going in the right direction. But I hope you're learning something and making some progress on that. So today we're going to continue with our lesson on exponents. Uh, Before break, we looked at product of exponents and negative exponents, and when your exponent is zero. So we're basically looking at whole numbers when exponents are whole numbers. Today we're going to look at what does it look like when we have exponents that are fractions. So when we look at fractions, we have two options. So here we're going to look at a little whiteboard here and look at the difference between two types of rational and radical exponents. Okay? So we've all seen what a square root is, right? So that's a square root of 25. We know the square root of 25 would be 5. Okay? This is in radical form. Okay? It's in radical form. It's in a square root. Okay? We also can write square root of 25 in what's called rational form. Okay? So this is rational form over here where your exponent is in the form of a ratio. Okay? A ratio is just a fraction, so it's in the form of a ratio. So we have radical form, rational form, and these both, the solution for both of those would be the same. Okay? Square root of 25 is 5. 25 to the half power is also 5. So basically what we have is we have the square root of 25 in radical form is the same as 25 to the half root in rational form. Okay? So now, using that as our starting point, let's take a look at example 1. And what we're going to do is we're going to just look at some examples in terms of how to change radical into rational form and how to change rational into radical form. Okay? So, as we start in example 1, and there's examples on example 1. I think there's 4 examples you can take a look at to help you with this, but we're going to go through 4 examples right now. Okay, so we have example 1a is a to the half power. Okay, so this would be in rational form. What we're going to do is we're going to change it to radical form. So that would just be the square root of a. So that's all we're going to do in example 1 is changing it from rational form to radical form. Okay? 1b, square root of 22. Radical form, we're going to change it into rational form. So when we have a square root, we basically say 22 to the half power. Okay? Radical form, rational form, rational form, radical form. Here we have, again, we have a fraction. So it's in a form of a ratio, so it's in rational form. We're going to apply this 1/2 to everything that it's right next to. And because it's in parentheses, that means we apply this 1/2 to this whole value here. Okay? So that would look like square root of 7w, because 1/2 is going to apply to this whole thing. All right? Here we have 2 to the square root of x. Okay? This square root only applies to the x. So this is in radical form. We're going to change it to rational form. We know that the square root of something is the same as something to the 1/2 power. Because this is different than this because here we don't have any parentheses. Here we do have parentheses, so this applies to this whole thing. In 1D, this square root only applies to the x, so the 1/2 only applies to the x. It does not apply to the 2 here. Okay, so that's example 1, changing exponents from radical form to rational form. Now, what we have here is in example 2 is we're looking at using radical and rational forms of exponents with something greater than a square root. Okay? So here we have 3 outside of our square root. That basically is telling me this is the third root of 27. So when we look up here with the square root, that basically is a 2 up there. But we don't need to put the 2 because we know that just a regular square root, we put a 2 here. Okay, so third root of 27 means here we would put it in 27 to the 1/3. Okay, here in radical form, we write it as 16 to the 1/4. So now, basically what we're looking at in example 2 is, this basically is saying, what number to the third power equals 27? Well, if this is odd, then we know it's going to be an odd number. So the answer there would be 3. 3 to the third power equals 27. Here we have 16 to the 1/4. Basically saying, what number to the fourth power equals 16? Well, if this is an even number, we know that our answer is going to be even. So that answer is going to be 2. And you can take a look at those were the 2 examples, I believe, in example 2, A and B. So here we have our guided practice. If we have 64, if we rewrite that, this is like saying, what number to the third power equals 64? Well, we could write that as 64 to the 1/3. Because this is even, we know that it's going to be 2, 4, 6, 8. And that ends up being 4, because 4 to the third power equals 64. Okay? 4 to the sixth power, or 4 to the third power equals 64. Last one, example 2b. 10,000, the fourth root of 10,000, we could rewrite it 10,000 to the 1/4. If this ends in 0, we know it's going to be 10. We know it's going to end in 0. Just like if this was ended in 5, we would know that the answer would be starting with a 5 as our base. So 10,000 to the 1/4, that answer's 10. Okay? Because 10 to the 4th equals 10,000. 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. Okay? So we're going to go over right now identifying in example 3 what our base is here. Those are our bases. So let's take a look at example 3 now. Okay? Now, when we look at our examples here, okay, in example 3, we have even and odd, okay? So if we start off with 2 as our base, we know all of those exponential numbers are going to be even. 2 squared is 4. 2 to the third is 8. 2 to the 4th is 16. So anytime we have 2 as our base, we know our answer is going to be an even number. Same thing with 4. 4, if 4 is our base, 4 squared is 16. 4 to the third is 64. Same thing with 6. 6 squared is 36. 6 to the third is 216. What do you notice about 6s? What do they all end in? 6s are always going to end in 6. So you can tell if your answer ends up being ending in a 6, you know it's going to be a multiple of 5, or excuse me, a multiple of 6 right here. Let's look at the odd ones. 3, if 3 is our base, 3 squared is 9. 3 to the third power is 27. 3 to the fourth power is 81. They all end in odd numbers. Just like our even ones, all end in even numbers. Take a look at 5. What do 5s end in? 5 squared is 25. 5 to the third power is 125. Write these down on your homework sheet so you know what your factors are going to be. Okay? 7. 7 squared is 49. 7 to the cubed is 343. If we have an odd base, we're going to end in an odd number. Okay? If we go higher than that, if we say 10 over here, just like what we saw in example 2, we know it's going to be 100, 1,000. We know it's going to end in a 0 if it's a multiple of 10. So now, let's go down to example 3. Okay, let's take a look at example 3. 125 to the 1/3. Well, take a look at what our base is. What does it end in? It ends in a 5. So therefore, you know nothing else is going to end in a 5 except 5. So the 125 to the third root is 5. What that means is 5 to the third power equals 125. 1296 to the 1/4. What rule did we talk about up here? If it ends in a 6, 6 is going to be my base. So the fourth root of 1296 is 6 because 6 to the what power? Fourth power equals 1296. 2 more. 27 to the 1/3. It's an odd number, so you know it's going to be odd. What number cubed equals 27? 3, because 3 cubed equals 27. Last one, then we'll get you going on your homework. 256 to the 1/4. 256 to the 1/4. Well, if it ends in 6, you think that it would be 6. But no, 6 to the third is 216. So 6 doesn't work here, but we know it's going to be even. It actually comes out to be 4. Because we're looking at what number to the fourth power equals 256? 4 to the fourth power equals 256. So write these down. I would pause the video, write these down so you know those rules as it affects what your base is, right? If you have an even base, it's going to be even. Odd base, it's going to be odd. 5 is going to end in a 5. If it's a 6, it's going to end in a 6. All right? So go back to your Google Classroom. Take a look at the assignment. Let me know if you have any questions or any problems. We'll set up an appointment with you. So with that being said, have a good day. Have a good weekend. Let me know if you have any questions.